Hello, this is Paul here, and today I'm going to be looking at this transformer I picked up locally. It's a power transformer, and it's a 240 volt step down to 120 volt. It's a 3S 1F type transformer. And so that means that it's 3,000 kilovolt amps, or 3 kVA amps, and it's a single phase unit. As you can see here on the input, you have, on the primary of the coil, you have two coils. There's H1 to H2 and H3 to H4. On the secondary, or the output, the low voltage side, you have X1 to X2, X3 to X4. So there's two coils on the secondary and two coils on the primary. And the way this works is, on the high voltage side, you can run 240 across H1 and H4, and actually you can run 240 or 480. And just tie H3 and H2 together, which makes one equivalent series. The two are in series, so it creates one equivalent coil on the input or on the primary. And then on the output, you can pull off the full. If you put 480 in, you can get 240 out across the entire X1 to X4 if you tie X2 and X3 together, which again makes comparable to a single coil output on the secondary. Of course, you can separate these, and you can have different options. So you can put 480 across the entire thing by tying H2 and H3 together and running the line coming in to H1, H4. Or you can use, and on the output, you would get 240 if you tied in X2 and X3 and put the load on X1 to X4. So basically, it's a half step down. Whatever you put in on the primary, you're going to get half as much voltage on the secondary. So if you put 240 in on the primary, you get 120 on the secondary. By tying these two secondaries in parallel. Tie H1 and H4 together, H3 and H2 together, pull your load off X1, I'm sorry, not X1 and X4. So, of course, here and here, I'm sorry, you can cross X1, X3, and X4 using a 3-wire line, and you can put a neutral here and have a hot here and a hot here, and pull out 240 across the whole thing, or 120 across either leg. So you get that option by tying these two together. That would be what running 240 in. So it can even be a 1-to-1 match. Anyway, I'm going to be testing this transformer to make sure it's still good. And I don't really have any use for a transformer that pulls 3,000 kilovolt amps, which you see right there. That's a lot of power. That's 6.25 amps on a 240 input, with an output of 12.5 amps at 120 volts. That's a lot of power, and the draw on my mains with this transformer would be incredibly high. So what I'm going to do to even test it, the first thing we're going to do is check the coils individually. We're going to check all 4 coils, X1 to X2, X3 to X4 on the secondary, H1, H2, H3 to H4 on the primary, make sure that all 4 coils are working, that they're not shorted or open. And we'll check them with a simple ohms meter. then to check the voltage drop and make sure that this is putting out half the input, I'm going to use my little box here, which has a VAC, and it also has a light bulb option for current protection, which I can throw on and off with the switch. We won't use that. Got a little cheap voltmeter here to let me know what voltage I got coming out of the VAC. This is on an isolation transformer for my mains, which will only put out a little over a couple amps max. So this system will not allow this unit to draw more ampage than I want. It's going to be, as this thing starts drawing more and more power from the mains, this system will drop in voltage accordingly and keep the current lower. So it sort of works like a buck converter, but not quite. See my old tube radio system that I've been working on there. That's an antique radio, but so anyway, I'm going to hook this up, pull the screws out of here and expose the wires, and we'll start testing. So I'm going to put this video on pause while I connect that up, get it ready to test, and then we'll be back to see what we get. Okay, here's what I got. I put the primary wires in the order that they go, 1, 3, 2, and 4, and clamped them to the back there where they be nice and safe, and they shouldn't move around without too much, they shouldn't move around. This is a resin sealed, it's like, I believe, resin and sand mix, sealed transformer. So it's made for indoor-outdoor use. Actually, it's made for outdoor use, but it of course work indoor. It has a tab in the front and back, which now that ruler is covering one of them, so you can mount it vertically on a wall or up on a pole. And anyway, here, that's the primary there. These are the secondary. I got them in the same order from top to bottom, 1, 3, 2, and 4. So we're going to check the resistance. This is the primary first coil here, primary second coil here, secondary first coil is here, secondary second coil is here. And we will connect them up to my voltometer here, and we'll check the voltage. They should be the same on both primaries, and probably close to half as much on both secondaries. Okay, I'm back. I've got my cables connected here. I have 2 alligator cables connected to the first coil of the primary, and we're showing 2.8 ohms. And I had to switch the wires around a little bit here. I kind of told you wrong. The primary coil is H1 and H2, and the second primary coil is H3, H4, which are ones with no lead, no connectors on them. And I had to switch these around too. They also go X1, X2, secondary first coil, X3, X4, secondary second coil. They show them crossed on the diagram back there, but that's just how you time together to get different voltage drops. This is a sand and resin dry cell, or dry transformer is what they call it. It is a single phase, so I can throw in single phase mains AC in here and play around with it to check everything. But we're going to continue checking the resistance. Right now, field 1, or coil 1 of the primary is showing 2.6 ohms. So the second test I want to do is see if coil 1 to coil 2 is shorted out. And the way I'm going to do that is by actually jumping from coil 1 to either one, it doesn't matter, of the leads on coil 2. If there's a short, I'll get a reading, but I have no reading, so there's no short. That's assuming coil 2 is not open, which we will check right now. Okay, connecting coil 2, and we got 3.1 ohms. The resistance is so low that just moving the connectors around is going to change the value, see. So they're about the same, they're matched. Now we will look at, and there's no short because both coils are good, but there's no resistance between them. There's no leakage between those two coils on the primary side. We will check also across primary to secondary. But the next thing we want to do is check the first coil on the secondary. So we'll hook that up. Okay, and it's jumping around 3 ohms, which is, I would imagine, about right. And we'll check the next coil here. And I'm taking care that though these are close, that they're not touching. Okay. And on that one we got 3.2 ohms, 3.1 ohms. So both coils seem fine on the secondary of the transformer. Now I'll do the same check for a short between the two coils on the secondary, and we have no resistance or zero load, overload. So there's no short. Okay, so we're going to leave it on one of those coils. We know that actually I'm on coil 2, and we'll check it to the primary. Nothing. Check it to, and if there's nothing here on the second coil of the primary, there can't be anything here because these are not shorted either. So now we will leave it, we'll put it on this one. It don't really matter, but just so you get an idea of what I'm doing, we'll move this to the first coil on the secondary, and again, no reading. So there's no shorts between the two primary coils or the two secondary coils, or from either of the primary coils to the secondary coils. This is a good transformer. It has no issues as far as short circuits is concerned. Okay, the next thing we want to check is voltage in versus voltage out. This is a dangerous, you see the danger down there? This is a dangerous transformer. It draws a lot of current. It will kill you in a heartbeat if you don't know what you're doing. So if you do test something like this, make sure you know what you're doing. You can see that I'm using, a ruler here to hold the wires apart with a metal clamp. Big no-no, right? And down here, a clamp with a wire almost popping out of it now. And those wires could short out at any time, right? Big risk of danger here. The reason I'm okay with this is because, one, I know what I'm doing. And two, I'm protecting it through a VAC and a light bulb setting. And I'm not going to be throwing my full 120 volts mains across the input. If I did, at 120 volts, it's going to draw around 25 to 26 watts, amps, I mean, because it's a 3 kilovolt amp transformer. It would trip my breaker, basically, because that's more current than my breaker box will provide to this transformer. So I can't throw 120 volts input. And I could throw 240 volts across the input and wire it for 240 in, and it would be 12.5 volts amps of drain to give me 3 kilovolt amps. However, I don't have 240 volts set up in my lab. I don't use 240 volts, and I don't need 240 volts. I see a whole lot more voltage of that in some of these old tube radios that I work on, sometimes up as much as close to 500 volts, 400 volts, but it's DC. And that still runs on 110 or 120 AC, depending on how old the units are. That one is old. So what am I going to do? If I can't put 120 volts in here to check it, 240 to see if I get 120, and I sure can't put 480 in there to see if I get 240, what can I do? How can I check the voltage drop across this? Well, it's very simple. This is a 2-to-1 transformer. So whatever I put in, I should get half as much out. So that's what we're going to do. I have a line cord plugged into my VAC, and all I have is stripped wires. But I am going to use wire nuts. So I'm going to set the phone down, connect this to one of the fields, and we're just going to do one field at a time to see what we get on the output. We might go across the whole thing, but I got to be careful that I don't draw too much power. So bear with me while I hook up these wires. I'll be right back. Okay, I've got this system energized. This transformer now has a little bit of voltage going into the primary. I set my meter on AC volts. See, I'm 0.16 volts on the output of this first field. And according to the meter, I'm putting in 0.2 volts. So that sounds about right. As you can see, the little light bulb glowing because I am using the current limiting bulb. But I'm going to turn up this voltage to about 20 volts. Across that primary. Okay, so right now we have around 20 volts. Going across the primary, the bulb's still engaged, so we still have current limiting. And lo and behold, look at the output voltage. Exactly half. So this transformer is functioning fine on that field from the first coil on the primary to the first coil on the secondary. So now what we're going to do is switch to the second coil on the secondary, and we should still have roughly 10 volts. So I'm going to put this in, I'm going to put this in pause, and I'll be right back once I hook up those wires. I don't feel like doing that with all these bare wires showing while I'm holding the camera. Be right back. Okay, I switched the wires for my voltmeter to the second coil. I'm looking carefully because appear to be missing one of my wires here. Oh, it's up there. Okay, that's fine. It's safe up there. As long as it ain't touching anything, I'm happy to go. So my first coil on the secondary, the wire finally popped out of there, and it's sitting up here in the air, which is nice and safe. Not enough voltage to do any arcing across to the primary, so we're good to go. 0 volts. Well, why is it 0 volts? Because I shut power off while I did that. Wasn't going to do that test with live power or that connection. So we turn it back on, and we're back to 20 volts. Come over here, and the second field is putting, the second coil on the primary is putting out 10.59 volts, exactly what we would expect for a 20.3 volt. So, if someone tells you that you can't check a transformer like this, or even a bigger one, because of the power consumption requirements, no, that's not the case. What you can't do is give it the inputted amount of voltage that it's designed to use if you cannot provide the amount of current that that's going to take. And this is an issue that a lot of people have. I'm going to go ahead and shut this off. But this is the issue that a lot of people have with transformers. They don't understand how transformers work. Well, I got it all put back together, and before I did, I went ahead and tested it with higher voltages, pushed it up as high as I dare do, and everything was fine. So this transformer is done. Testing this transformer, and I appreciate you watching my video. Thank you.